Alright, this is Algebra 2, Lesson 29, and this lesson is about uniform motion problems, but our key formula in these, they're going to be distance 1 plus distance 2 equals our total distance, k. Well, they're not hard. Before we were doing ones where the distance of one person was equal to the distance of the second person that was traveling. In this, we're going to have the first person went part of the way, and then the second person went another piece of the way, and then we're going to get a total distance. Okay? It'll make sense once I start doing one of the problems. Alright, so the first example problem says, Napoleon walked part of the 60 miles, and I'm on page 132, and this is example 29.1, so if you want to turn in your book to that page. Alright, so it says, Napoleon walked part of the 60 miles to the site of the battle and rode the rest of the way on horseback. He walked 3 miles per hour and rode 9 miles per hour. If the total time of the trip was 8 hours, for how long did he walk? Alright, so we're going to break that down. It says that he walked part of the way. Okay, so he started here, and he walked that far. And then he got on the horse, and he rode some more, and he rode that far. Okay, and the whole total of all of this, okay, total distance that he traveled was 60 miles. Okay, that means his distance walking and his distance riding equals 60. Okay, so we could go ahead and write that. Distance that he walked plus the distance that he rode equals 60. Okay, and we know that we're going to have rate times time equals distance. Okay, and we're going to have a rate for walking and a rate for riding, and then a time for walking and a time for riding, and then a distance walked and then a distance that he rode. Right? Alright, so then it says he walked at 3 miles per hour and rode at 9 miles per hour. So I can go ahead and say that my rate for walking was 3 and my rate for riding was 9. If the total time of the trip was 8 hours, that means that the time that he walked plus the time that he rode equals 8. Okay, so we've got that. For how long did he walk? So we want the time walking. That's what we're looking for right there, the time that he walked. Alright, so from this, we're going to have to figure out a formula. Now, our key formula is going to be the distance that he walked plus the distance that he rode equals 60. Well, if distance equals rate times time, we can say the rate that he walked times the time that he walked plus, so that's here, just substituted that, okay, the distance that he rode, which would be the rate times time of riding, so the rate that he rode times the time that he rode equals 60. Okay, so that's our key equation right there. Rate 1 times time 1 plus rate 2 times time 2 equals our total distance. Alright, from there we can start filling in some of these missing numbers. So the rate that he walked, we know that is 3. The time that he walked, we don't know that. So we're going to say time walked plus the rate that he rode, which is 9. We don't know the time that he rode, but we can change this equation around to make it so that we do. So if we want the time that he rode, we could say time riding, and then we just subtract time walking from both sides. So that equals 8 minus the time that he walked. Okay, so we're going to fill that in right here and say time that he rode would be right here. Okay, we got rate right there and time that he rode. So we're going to say the time that he rode. The rate that he rode, which is 9, times the time that he rode, which is 8 minus TW. Okay, equals 60. Okay, so now to solve this, we're going to distribute right there. So we're going to say 3 TW plus 9 times 8 is 72 minus 9 TW equals 60. So all I did was distribute this. 9 times 8, 72, negative 9 TW. Okay, now I'm going to combine like terms. 3 and negative 9 would be negative 6 TW plus 72 equals 60. Now I'm going to say minus 72. And I am going to get, let me move my camera a tad here. You guys can see. There we go. Okay, so then I'm going to get negative 6 TW equals negative 12, and then I divide by negative 6. Negative and a negative makes a positive, so the time that he walked equals 2, and that's all I needed to know right there. So that's the answer to that one. All right. Whoopsie. Okay, let's try one more example. All right, so this one says, Edward Longshanks and Queen Eleanor were 54 miles apart. Edward began the journey to the meeting place at 8. At 3 miles per hour. 2 hours later, the Queen set out to meet him. If they met at 4, how fast did the Queen travel? All right, we're going to need a diagram for this one. All right, so we've got Edward, and he's going this way. And then we've got the Queen, and she's going that way. Okay? And it says they were 54 miles apart, so we know that the distance of the Queen and the distance of Edward is going to be 54 miles. All right, and it says that Edward began the journey to the meeting place at 8. Oh, they're meeting at 8 at 3 miles per hour. So he started at 8 and he got there at 4. So that'll be 8, 9, 10, 11, 12, 1, 2, 3, 4, right? So he started at 8 and he got there at 4. So 8, 9, 10, 11, 12, 4 hours, 8 hours. Okay. So let's go ahead and get our stuff together over here. So we've got distance equals rate times time. And we're going to have the distance of Edward and the distance of the Queen. And then we're going to have the rate of Edward and the rate of the Queen. And then we're going to have the time of Edward and the time of the Queen. All right. So this tells us that his time was he began the journey at 8 a.m. and he got there at 4 p.m. So he was walking for 8 hours. So the time of Edward is 8. And then it says that he was traveling at 3 miles per hour. So the rate of Edward is 3. Okay. And then we've got 2 hours later, the Queen set out to meet him. So that means she started at 8, 10 o'clock. Her time is 6 hours. Okay, because it was 2 hours later when she started. How fast did the Queen travel? So the rate of the Queen is what we're trying to find. And we know that the distance of Edward plus the distance of the Queen equals 54 miles. Okay, so we're just going to replace distance of Edward with the rate times the time of Edward. So rate of Edward times the time of Edward. And then we're going to add that to distance of the Queen would be the rate of the Queen times the time of the Queen. And that's all going to equal 54. Okay, now we're just going to fill in our variables. Rate of Edward is 3. Time of Edward is 8. Plus rate of the Queen, that we don't know that. That's what we're trying to find. Times the time of the Queen, which is 6, equals 54. 3 times 8 is 24 right here. Plus 6 times the rate of the Queen equals 54. Now we're going to subtract 24. We're going to get 6 times the rate of the Queen is equal to 30. Now we'll divide by 6. And we'll get the rate of the Queen equals 5. Let me double check that. Yep. So that's all we were looking for. So that's our answer. Rate of the Queen is 5. Alright, go ahead and try the practice problem on page 133. Pause the video, and then I'll work it for you. Okay, practice problem. It says at 1 p.m. Chester left the roundup and began the 66-mile trip to Dodge City. Alright, so we've got Chester. He's going this way. And then at 2 p.m. Marshall Dillon left Dodge City to meet Chester. So here's where Marshall Dillon went. Alright, Marshall Dillon's speed was twice that of Chester's. When at 9 p.m., how fast did each man ride? Okay, so at 1 p.m., let's see, we know this whole trip is 66 miles. So we know that the distance of Chester plus the distance of Marshall-Dillon equals 66. We know that we're going to need distance equals rate times time, and we're going to need the distance of Chester and the distance of, I'm going to use an M for Marshall-Dillon instead of a D because DD is just too confusing. And then we're going to need the rate of Chester and the time of Chester and the rate of the Marshall and the time of the Marshall. Okay, so it says 66 miles. Chester left at 1. They met at 9 p.m. So 1 to 9 p.m. would be 8 hours for Chester. And then Marshall-Dillon left at 2 p.m. So that's an hour left. So less 1 hour less if he left at 2 and got there at 9. That would be 7 hours for the Marshall. How fast did each man ride? That means we're trying to find both of these rates right here. Alright, I think that's all that we need. Oh, Marshall-Dillon's speed was twice that of Chester's. So 2 times the rate of Chester equals the rate of the Marshall. Marshall-Dillon's speed was twice the rate of Chester's. Marshall-Dillon's speed was twice that of Chester's. Yes, 2 of Chester's equals 1 of Marshall. Alright. So now we're going to rewrite this equation with, instead of distance, we're going to do rate times time. So the rate of Chester times the time of Chester plus the rate of the Marshall times the time of the Marshall equals 66. And this is your key equation right here, guys. That's the key equation that you're going to use. Alright, the rate of Chester, do we know that? No. The time of Chester, yes, we know that is 8. Plus the rate of the Marshall, we can fill that in because we know that's 2 times the rate of Chester. And now the time is going to be the time of the Marshall. So I use this equation right here for that. Time of the Marshall is 7. And that's times 7. So we're going to keep that in parentheses, equals 66. Alright, so we're going to say the rate of Chester. No, we're going to multiply that. We're going to say 8 times the rate of Chester, RC, plus 2 times 7, which would be 14, RC, equals 66. Then we're just going to add those together, be 22. Then we're going to divide by 22. And we're going to get the rate of Chester equals 33. So Chester's going 33 miles per hour. We're not done yet. We still have to figure out the rate of the Marshall. That means that the rate of the Marshall is double the rate of Chester. That should be 66. Let me double check that in my answer key here and make sure that I am right. So I didn't look that one up. Oh, nope. Totally wrong. You guys probably caught that. 66 divided by 22 would go 3 times, not 33 times. That'll be 66. Yep, so the rate of Chester is 3 miles per hour. That means the rate of the Marshall is 6 miles per hour. There you go. So be careful with little technical mistakes like that. Alright, so we covered both lesson 28 and 29 in class, and the homework was lesson 29.